Reactions of 2-degree and 3-degree alcohols. First of all, let us acquaint with 2-degree and 3-degree alcohols. 2-degree alcohols. CH3, CH, OH, here CH3. This is a kind of 2-degree alcohol because the carbon linked up with hydroxyl group is linked up with 2 carbon atoms. That is why this is a kind of 2-degree alcohol. This is also known as secondary alcohol. Carbon linked up with hydroxyl group is linked up with 2 carbon atoms. That is why this is 2-degree alcohol. Now 3-degree alcohol. CH3, OH, CH3, CH3. This is a kind of 3-degree alcohol because here carbon linked up with hydroxyl group is linked up with 3 carbon atoms. For this reason, this is a kind of 3-degree alcohol. This is also known as tertiary alcohol. Its name is 2-methylpropanol. 1, 2, 3. So its name is 2-methylpropanol. And its name is propanol 2 or 2-propanol. Now let us see reactions of 2-degree and 3-degree alcohols. 2-degree alcohol. This is a kind of 2-degree alcohol. Its name is 1, 2, 3, 4. Butanol 2 or 2-butanol. When this is treated with concentrated sulfuric acid and the reaction is heated at 100 degrees Celsius temperature, then sulfuric acid brings out water from this alcohol, and it occurs in 2 ways. One way is this water from carbon 2 and carbon 3. Then this is obtained. Here carbon-carbon single bond turns into carbon-carbon double bond. This is butene 2 or 2-butene. 1, 2, 3, 4. Butene 2 or 2-butene. Another way to take out water from carbon 1 and carbon 2, and in this case this is obtained. this carbon-carbon single bond turns into carbon-carbon double bond, and water gets free as byproduct, which is taken out by sulfuric acid. The name of this product is butene 1 or 1-butene. Now the question is, which one is the main product? Butene 2 or butene 1? Actually, butene 2 is formed around 85%, but butene 1 is formed around 15%. What is the reason behind this? Let us see mechanism of the reaction. Mechanism of the reaction. Step 1. Sulfuric acid ionizes to proton and bisulfate ion. Bisulfate ion. Structure formula of sulfuric acid. This is oxygen, hydrogen, oxygen, sulfur, oxygen 3, hydrogen, hydrogen, oxygen, sulfur, oxygen 3, hydrogen. So sulfuric acid ionizes to form proton and bisulfate ion. Step 2. Proton combines with alcohol. That is, this proton combines with this oxygen. That is, alcohol suffers protonation to form this protonated alcohol. Oxygen gets positive in charge. Because of this positive charge, this carbon-oxygen bond experiences heterolytic fission and water gets removed, and this carbon gets positive in charge. This carbocation is formed. Now, step 3. This carbocation is attacked by bisulfate ion, oxygen, SO3, hydrogen, bisulfate ion. When bisulfate ion takes this hydrogen, then this carbon-hydrogen bond moves here to form carbon-carbon double bond, and as a result, this is formed. Butene, which is 85%, and when this bisulfate ion takes this hydrogen, then this carbon hydrogen bonding electrons move here to form carbon-carbon double bond, and as a result this compound is obtained. Butene 1, butene 2 85%, butene 1 15%, and sulfuric acid is formed, which brings out water. Now, why this is 85%? Why this is 15%? In this compound we see double bond is at the middle, and on the right side one methyl group, on the left side one methyl group. So this compound is balanced, that is stable compound. As this is balanced stable compound, it is formed in large quantities, that is, then this hydrogen is more responsive. This is more reactive to form butene 2, because butene 2 is a stable compound. For this reason it is formed in large quantities. But in this case, double bond is at one end. On the right side no methyl group, no alkyl group, but on the left side one alkyl group, ethyl group. This compound is not balanced, that is, this is comparatively less stable than the first one. As it is less stable, it is formed in small quantities, that is 15%. This is less alkylated alkene, this is more alkylated alkene. According to Saint-Jacques rule, more alkylated alkene will be the major product. So butene 2 is the major product. Reactions of 2-degree alcohol with concentrated sulfuric acid. Now let us see reaction of 3-degree alcohol with concentrated sulfuric acid. 3-degree alcohol. When this is treated with concentrated sulfuric acid and the reaction is conducted at 100 degrees Celsius temperature, then first of all this oxygen of alcohol is protonated in this way. Oxygen becomes positive in charge. Now this carbon oxygen bond suffers heterolytic fission and water gets removed. Water, and this is obtained. This carbon becomes positive in charge. Now bisulfate ion, oxygen 3, sulfur, oxygen, bisulfate ion. Bisulfate ion brings out any of the hydrogen atoms, because all the hydrogen atoms here are same in property. So any of the hydrogen atoms are brought out by bisulfate ion. Suppose this hydrogen is taken out by bisulfate ion. Then sulfuric acid will be formed, plus these carbon hydrogen bonding electrons move here to form carbon carbon double bond, that is main product CH3 carbon, here CH3 carbon carbon double bond with this carbon, two hydrogen atoms. This is the product of the reaction. Its name is 1, 2, 3, 2-methyl propene. Two-methyl propene. 2-methyl propene is obtained when 3-degree alcohol is treated with concentrated sulfuric acid. This is all about reactions of 2-degree and 3-degree alcohols with concentrated sulfuric acid. No more today. Thank you very much.